I'm going to do is, may I start with n equal to 0? Okay. Then, as far as x is concerned, can I write x to the what power? 2 plus 2n. Is that right? Does that work? When n is equal to 0, it's 2. Subsequently, every increment of n leads to an increment of 2 in the power, right? That's a way to think about it. Okay, what else? Well, I definitely will have a sign which is -1 to the what power?
To the
N's power. That takes care of the sign, right? And then I will have obviously some factorial down there. What factorial?
N factorial.
Huh?
N
N
minus
factorial.
2.
That'll work. Right. This is n equal to 0, n equal to 1, n equal to 2, n equal to 3. You have 3 factorial, and so on, right? So that works. But there's an issue here. How do you deal with this guy here? I mean, apart from sign, I've already taken care of, right? But then you have these annoying fractions. And all these fractions have denominator what? 2? How many of them? 2 to the what power? You see that n equal to 0? Nothing. N equal to 1? There's a 1, right? N equal to 2, there are 2 of them. N equal to 3, there are 3 of them. N equal to 4, there are 4 of them. Alright? So it looks like what? 2 to the nth power? That would take care of these 2 things. Is that right? How do you take care of these guys? When these are all what? Odd numbers. Right? When n equal to, let's say, 1, you have 1 of them. When n equal to 2, you have 2 of them. 2 odd numbers, 1 and 3. When n equal to 3, you have the first 3 odd numbers. Right? So let's temporarily write it as this. 1 times 3 times ... up to what? The nth odd number. What is the nth odd number? 2n minus 1. Huh? Well, there is some issue here, obviously. You know, let's see. If n equal to 2, 0, 1, 2, that will be x. That will be this term, right? If you have 2, then this indicates that this 2 plug in this 1 is what? 3. Is that right? So the first few odd number until 3 multiply together. That's right. But there's an issue when n is equal to what? 0. I mean, 0 is kind of odd, right? You know? So make a question mark here. You need to fix. All right? Now this is kind of ugly, right? But let me tweak this. Let me rewrite it. N equal to 0 to infinity, right? There's no problem with this part. This part is quite clean, so let me copy over. Okay? And this 2 to the nth power is okay as well. Now look at this. I have 1 times 3 times 5 times ... up to 2n minus 1. Right? So for counter n, then I have the first n odd numbers multiply together. Now, let me insert something. Insert 2 here. insert 2 here. Sorry, insert 4 here. And insert what? 6 here. And this will insert 2n minus 2. Right? May I insert 2n? Yeah. And then whatever you insert, you have to divide back. 2n minus 2n. Alright? So once you insert this, the top becomes an honest factorial, which is what factorial? 1 times 2 times 3 times 4 times 5 times 6 times up to what? 2n. Aha, 2n factorial. That's 2n factorial. Right? And what happens down here? How many factors are there? There's 2 times 1, 2 times 2, 2 times 3. How many factors? N factors, all even numbers. Alright? The first n even numbers multiply together. Each one of them has a factor of 2, correct? Right? So therefore you have what? Extra 2 to the n's power. Now account for all these extra 2's. But apart from those 2, you have what? 1. This one is 1 times 2. This is, this is 2 times 1, 2 times 2, 2 times 3, 2 times 4, up to what? 2 times n. So you have those 2, 2, 2 are already taken care of. But 2 times 1, 2 times 2, 2 times 3, you have the 1, 2, 3, right? Up to what? N, what is that? Isn't that n factorial? Yeah? Now this also fixes that problem because, for example, if n is equal to, say, 1, right? This means from 1 to 1, right? Okay? And then if n is equal to 1, what do you have here? 2 factorial. And you do have this one. And this part is new. This part is from here. Is that right? Okay. Now, this one, when n is 1, that's the second term there. When n is 1. N equals 0, n equals 1. When n is 1 there, this one is meant to be the first one in odd number multiplied together, which means 1. Right? Now, is this consistent with here? If n is 1, then here means 2 factorial. Here means 2 to the first power. Here means 1 factorial. That's 1. That's indeed 1. So that's good, right? But remember, previously we said that when it's a 0, it's a little bit annoying, right? Because what do you mean 0? That's the only counter value where this appears to be problematic. When n equals 0, wouldn't this expression means what? The negative 1 is kind of odd. That's not what I mean. Is that right? Okay. As a matter of fact, when you have the first term x squared, when n is equal to 0, this is x squared, right? And this one is nothing. This one is nothing. 0's factorials have x squared, right? Now, n to the 0th power, that's nothing as well. That's 1. And so I wish this one is 1. That's what I mean. When n is 0, this piece means 1, right? Now, is that taken care of automatically? You see that n is equal to 0, what is this? 2n is what? 0, 0 factorial is what? 1, right? And 2 to the nth power? 1. 0 factorial? 1. It's good. Right? So it doesn't even have that problem. Right? So this is it. And therefore, clean it up. Here's the answer. N goes from 0 to infinity. Negative 1 to the nth power, is that right? And then I have what? 2n factorial, that's one piece. And down here I have 2n, agree? Because this is 2n squared, that's 2 to the 2n, right? And then what else? I have n factorial appears how many times? Twice, so I square it. And then finally I have this x thing, x to the what power? 2 plus 2n power. And that's the final answer. Wow. This itself is not that important, alright? I mean, this is important. This is important, right? You see that, well, you know, this already gives you the pattern. This is not as important as that. However, I know for sure that some of, you know, quite some of you have to take, you know, calculus 3 and then afterwards 3E, 3F. 3F is what? Differential equations. A lot of students cry just when they have to, you know, work on power series solutions of ordinary differential equations, and they have to deal with this kind of thing, right? And you know, I know because I help students at a math labs, and I know a lot of students just get confused, and so this is a good practice. You know, starting here in this chapter when we first learn this thing, you have to know how to manage this sort of thing. You know, how to design a counter. It depends upon how counter is set, then you have to express the right-hand side, you know, appropriately. And how do you manage your thoughts in doing this? And I hope I illustrated you. You know, I throw in some ideas. I ask myself several questions as I work on this one. I ask you questions. That's the kind of questions you should ask yourself when you are called upon to, you know, clean it out into this.